We have a square-based pyramid with these coordinates and the apex here. Now let's draw a quick sketch so that we can see roughly what's going on. We've got a square-based pyramid, so we've got our square going here, our vertex somewhere up here being connected to all these points, and down here. I call this 0. This is A, which is 4, 0, 0. B, pull it over a little bit so it fits on. B, which is 4, 4, 0. And this point back here is going to be C, which is, figure out how to write this. There we go. C, which is 0, 4, 0. And our apex D, which is 2, 2, 5. There we go. Okay. Verify that the apex lies directly above the center of the base. So verify it's above the middle of this square is essentially what that's saying. How can we find the middle of the square? Well, we can find the diagonal OB or the diagonal AC and the midpoint of that. So the midpoint of OB is going to be halfway between 0 and 4 is 2. Halfway between 0 and 4 is 2. Halfway between 0 and 0 is 0. And that's exactly the same as if we find the midpoint of AC. Now that verifies that it's above it because this is 2, 2, 5 and this is 2, 2, 0. So they have the same x and y coordinates and just vertically above it. Find the volume of the pyramid. Well, the volume of a pyramid is 1/3 times the area of the base. The area of the base is the area of this square, which is 4 times 4, times by the vertical height, and the vertical height here is the point going from that midpoint OB up to D, and we just said that that is 5 because we're going from 0 up to 5. That gives us 80/3, or as a decimal, 26.7. Finally, part C. M is the midpoint of the HBC, so M is going to be this point here. And we need to find the coordinates of M first of all. The coordinates of M are going to be halfway between 0 and 4, which is 2, halfway between 4 and 4, which is 4, and halfway between 0 and 0, which is 0. For the second part of part C, find the exact length of MD. Now for MD, is this length here. We're going to want to do some right-angled triangles here. And we've got a right-angled triangle coming up here, where this is actually the right angle, because it's going up there. It's a bit hard to see at that angle, but it is. For that, we need the length CD, and we need the length CM. And we know CM is going to be 2. So let's find the length CD. CD is the square root of 0 to 2 is 2, so 2 squared. 4 to 2 is 2, so plus 2 squared. And 0 to 5 is 5, so plus 5 squared. So this is equal to the square root of 33, which means that MD is equal to the square root of, well, in this case, the hypotenuse is going to be CD. So the square root of 33 squared minus 2 squared, which is the square root of 29. Finally, now that we know that, we can do the last part, which is the surface area of the pyramid. First of all, we're going to find the area of one of those triangular faces, which is a half times the base, which is C to B, which is the length of 4, times by the perpendicular height of that triangle, which is that length MD we just found, root 29. So one triangle is 2 root 29. So the total surface area is going to be equal to 4 lots of that. So 4 lots of 2 root 29, because there are 4 triangles, plus the square on the bottom, which was 16. So we have 8 root 29 plus 16, which as a decimal is equal to 59.1 for our total surface area.